I would like to talk about debugging. Now, this is a topic that I'm an expert in because when I write my code, I make lots of mistakes and I end up spending a lot of my time fixing those mistakes. When I first was learning how to write code, nobody ever taught me how to do this. I just kind of figured it out and found some things that worked for me. You're probably in the same boat. You've probably been making mistakes in your code since about the first line of code you ever wrote, and whether you realize it or not, you've come up with some things that you do to help you fix those mistakes. My goal here is to give you some concrete strategies, some things that maybe you hadn't thought of that will help make you a little more efficient at finding those bugs and getting your programs back on track. When we say bugs, what we really mean is just an error or a flaw in your program. So we'll start with a quick bit of history and trivia that I always think is interesting. The term bug predates this story that we're talking about here, but when we started using it in the context of computer programming was in 1947, and Admiral Dr. Grace Hopper, who was a computing pioneer, was having trouble with a computer that wasn't behaving the way she was expecting. She opened it up and she found a moth that was inside there, kind of disrupting the electronics. So Hopper and her colleagues took that moth out, they taped it into their little logbook, and they made a note saying that this was the first actual case of a bug being found. And ever since then, that term kind of stuck. And when we talk about these as being computer bugs, there really are two types of bugs, or two ways we can describe bugs in our programs. There are compile time errors and there are runtime errors. And they each present kind of different challenges and different ways that we have to debug them. So the first type of error is a compile time error. And this is when your compiler can't translate your source code into machine code that the computer can actually run. They're caused by syntax errors or kind of semantics. So for example, if you're trying to write an if statement in Java, you need to have those parentheses. If you forget the parentheses, you've violated a syntax rule of the language and the compiler stops. It doesn't know how to handle that. In Python, an analogy would be maybe leaving off the colon at the end of an if statement because that's a syntax rule in Python. And similarly, the Python compiler or really interpreter won't know what to do with that, and it won't let the program run. Often syntax errors are just really simple mistakes, like again, forgetting semicolon, forgetting to put a semicolon at the end of a Java statement, or not indenting properly in Python. In any language, if you misspell the name of a variable or a method or something like that, that's a syntax error. For the most part, syntax errors are identified in your IDE. You've been seeing those little squiggly lines similar to like misspellings in Microsoft Word or something like that. Even though your IDE can identify these, a lot of times they can be really tricky to fix for a couple of reasons. One, the error message that you see may not make a lot of sense, especially if you're new to programming. It's sometimes they're sort of technobabble, right? Another problem, the second problem that makes these hard to fix sometimes is that sometimes the compiler message doesn't even point to the correct line, right? You might make a mistake on line 10, but the compiler is able to keep going after that, and it's not until a few lines later that it finally gets confused and realizes it doesn't know what's going on, and so it thinks the error is down here, but really you've made a mistake way back on line 10. And then sometimes one error may hide another error, and so you fix one and you realize there were actually 5 other errors that it wasn't even getting to because the compiler kept stopping. So those can be kind of tricky. They have to be fixed before your program will even run. So they are sequentially the first kinds of errors that we encounter. The other type of error we have is called a runtime error, or we also call these logic errors. And these happen when our program doesn't execute the way that we want it to. Runtime errors can have different symptoms, different ways that we know there's a problem. For example, it might crash or give us an exception and cause the program to actually stop running. but often the program does run. It just maybe gives us incorrect results, or something in the program doesn't behave the way that we expect it to behave. You have undoubtedly experienced runtime errors in apps or games that you've used. I use the example in a game of if you have an NPC that's like glitching and getting stuck in a wall or something like that. That's a logic error. That's a runtime error. It's not stopping the game from working, maybe, but it's not behaving the way that the game designers and the programmers intended it to work. Now, runtime errors can be really, really tricky to fix. Your IDE can't detect a runtime error because the code you've written follows all the syntax rules, and it will execute, or at least it'll start to execute. So as far as the compiler is concerned, the code is fine and there's no error. As an example, maybe you are going to add two numbers together, but instead of typing a plus sign, you accidentally type a minus sign. Well, the IDE sees that, and that's perfectly valid. The compiler sees that, no problem, I can do that. The computer doesn't know what your intent is. It just follows whatever instructions you give it. You know the program is getting the wrong results, so you have to go and find where your mistake is without the help of the compiler or the IDE. Now, I hate to say this, but if your program doesn't work correctly, it really is your fault, right? We've all had that experience where we know in our hearts that our code is correct. You've been looking at it for 20 minutes and you can see that it's right, but it's still just not working the way you want it to work. You have to remember, a computer is just a device that does exactly what it is told to do. If you're getting the wrong result, it's because the source code you created is flawed. That can be really frustrating and discouraging, but you have to remind yourself there's always an explanation for your program's behavior. And unfortunately, it's probably not because there's a dead moth in your computer shorting things out. The good news is, if we understand that the computer is just doing what we told it to do, that means we can fix it. We can find that error and we can correct the mistake. Because debugging can be so frustrating and so confusing, my goal here is to give you some tips and some strategies to help you figure out what's going on and get those errors fixed and get back to coding as quickly as you can. This is going to start with really using a coding process or development process that makes you less prone to make errors in the first place and makes it easier to find and fix those errors when you do. So this is going to start as soon as you really begin that first line of code in your IDE. And you have to accept that making mistakes and having to fix them is just part of the process. In fact, it might be the most important part of the coding process. Every programmer makes mistakes, from beginners to the most accomplished programmers in the world. If you've had me in an in-person class and you've seen me writing code live, you've seen me make all kinds of mistakes and then I fumble around trying to figure out what's wrong. You're probably sitting in your desk looking at the projector going, I can see right there what the mistake is. Okay, for me, good code doesn't just pop out of my head fully formed. Good code is the result of a development process, and that process includes making some mistakes. So stop beating yourself up about it and just accept that this is what we do. The next thing you can do as far as having a debugging mindset and a mindset that minimizes the amount of errors you make is to run your code often. Run it every time you make any kind of a significant change or you make significant progress, even though you're absolutely certain that nothing you did is going to be a problem, you run it anyway. If you type up 100 lines of code before you try running it the first time and then you get an error, you now have 100 lines of code that you have to go through and find that mistake. But if you just type a few lines of code and then run that, if you do have an error, you only have a few lines of code that you have to look at if something goes wrong. So run your code frequently. Don't let yourself build up a bunch of errors that you have to fix at once. Just work on a little piece at a time. And on that same note, when you start on a programming project, whether it's something you're doing yourself or an assignment for a class, think about how you can break that up into small tasks, right? And the idea is you want to work on just a little tiny piece, and you get that piece working before you move on. So maybe you start out with, I'm just going to get the user's input. I'm going to prompt them, I'm going to get the input, and I'm going to save that in a variable, and I'm just going to get that working before I move on to the next thing. It's really part of that same idea of running frequently and focusing on little bits of code at a time. Another thing you can do to help break up your task into smaller, more manageable pieces is to use methods or functions kind of liberally, right? Use them often. Identify the little tasks that you need to do in order to solve the big problem. And then for each one of those tasks, write a method or a function that just does that. A lot of times you can write and test a function by itself, and you can get that function working completely, and then you can incorporate it into the rest of your program once you know it's working. Okay, so you've got the right attitude. You're working in small pieces and fixing errors right away and not letting them build up. They're still going to happen, right? So what do we do once we have an error and we need to deal with it? So how can I approach that? The first thing I recommend that you do is clean up your formatting, right? When you're working on a section of code and you're making lots of changes to it or making lots of progress, a lot of times our indenting and our use of white space can get a little bit messed up. In a language like Python, this can directly cause errors since indenting is how we specify blocks of code. But even in a language like C#, messy indenting and poor use of white space can make it hard to visually identify how your code is running. So in this Python example, this second print statement is supposed to be part of what executes if that if statement comes back as true, but I haven't indented it correctly, so it's not going to work properly. In my Java or C# example here of an if statement, because I've put these curly braces in an odd spot and I haven't indented properly, it's easy to miss that, well, that block ends right there, and it leaves out that second print line statement, or it would be a write line statement in C#. And so it's really easy to miss that. Most IDEs have a feature that will clean up your formatting, so just use that. A lot of IDEs, including Visual Studio Code, have a setting where you can make it automatically format your file every time you hit save. I would encourage you to turn that on. The other thing to point out here is, aside from helping you debug, clean formatting is really, really important for just general readability, and you need to make sure that you clean up your code before you submit your work, and by that I mean submit it to your teacher, or if you're in a workplace, before you kind of submit that pull request to have that code be merged into the project. You need to have it cleaned up first. My next tip is to stop and work the immediate error. Don't gloss over an error with the intention of, oh, I'll just come back later and get that one. This can compound your problem, right? You can make other errors because of that error, and they start to build up. So just stop and focus on that one error until you get it fixed, and don't move on. Sometimes a fix requires a pretty big rewrite, and any additional work that you've done before you fix it might end up being useless anyway, so it just ends up wasting time. Similarly, if you find yourself in a situation where you have a whole bunch of errors, you need to just pick one and focus on fixing that one error instead of trying to fix it all at once. I usually start with whatever I think is the most important error, but you could also just, focus on whichever error comes up first in your program. It doesn't matter, but just pick one error and work that error until you got it solved. The single best tip I can give you, the most important single piece that you can take away from this, is to give yourself a way to see what's happening in your program. When your program is running, you can't see what the variables are doing. You can't see how program execution is flowing, so you don't know for sure where things are going wrong. In a different video, I'm going to show you how to use some of the tools in your IDE to help keep an eye on those things, but there's a really easy way to do this without getting into fancy tools, and that's just to use a ton of output statements, right? And by that I mean, and if you're in Python, print statements. If you're in Java, then print line or write line statements for C#. So for example, prior to a big calculation, just print out the value of all the variables that are involved. That way you can see, are the mistakes happening before the calculation or after the calculation. In a loop, print out your counter or your accumulator so that you can see how it's iterating. Print a message at the top of a method or a function. I can't tell you how many times I've written a really good method and then forgotten to actually call it, and I put a print line statement in there and I run my program and realize I'm never even going into the method. These examples here show an infinite loop, right? So I run my program and it just looks like it's frozen. Nothing is happening. Well, something's going on in this loop. So if I come back and add a little print statement or a print line or write line statement, then I'm going to see that that number is just the same every single time. I have forgotten to increment my counter for my loop. So that's an example of how using output can just show us and give us insight into what's going on in our program. And I like to say that output statements are free. They don't cost anything, so use them often. You can always go back later and delete them when you fix the issue, or comment them out if you think you might need to be debugging something similar in the same piece of code later. If you're working on a big program, it's smart to try and isolate that problem, try and run just the code that is giving you trouble. So we don't obviously want to delete things that we've written and that are part of our program, but you can comment out a lot of stuff that maybe isn't relevant to where you're seeing the error. So for example, maybe you skip the part where you're getting user input from the user and you're just assigning a value. That, for one thing, that saves you from having to type stuff in all the time when you run your program, and you can focus on just the code that has the problem. If you're calling a bunch of unrelated methods, and by unrelated methods I mean things that aren't related to the problematic code, just comment those calls out so that they get skipped. Your program probably isn't going to work the way you want it to work, but the piece of code that you're trying to debug, you can run that and focus on just that code. Nobody wants to hear this one, but my next advice or my next tip for you is to document your code, right? Very few programmers like to write code comments or documentation. But if you're looking at this code and you really can't figure out what's going on, take a few minutes out of your life to just write a single code comment for each line of code explaining what it is supposed to do. That forces you to look at each code and analyze each code, and don't just write what you think it's going to do, look at it and write what it's really doing. Something about that just shifts your brain enough to where you can kind of see, oh man, this line of code that I've been looking at all this time has an error that I just didn't even notice. This also has other advantages that are going to help with kind of the next step I'm going to tell you, and it can help down the road if you have problems with this code again later. At least you've got it all documented out and you can understand what you're supposed to be doing and try and figure out why it's not working the way you want. The last tip I have for you is the easiest one, but it's the one that people always forget, and that is to just take a break, right? You stare at a problem and you just become more and more and more frustrated. Something happens when your brain is like that, in that mode where you just kind of stop recognizing your code. You're seeing what you wanted to write instead of what you actually wrote. It's the strangest thing, but I see it all the time. You're just seeing what you want to see. On some level, I always think maybe you're sort of emotionally invested in the code, like you've spent a lot of time on it. You don't really want to accept it's wrong. You don't want to delete that code and start over. So your brain is just telling you that it's okay when it's clearly not. I don't think it's productive to sit there for 20 minutes looking at the same lines of code over and over. So do something that's going to give your brain a little bit of break from debugging. I don't care if it's taking a walk or wasting a little bit of time on Reddit or working on a different program. Go to sleep and start again tomorrow. Just do something that's going to clear your head, shift your attention onto something else, even if it's just for a few minutes. You will be amazed at how you can come back from grabbing a bite to eat, and you sit down and instantly you see what the problem was. It was there all along and you just were missing it. I also like to point out that this is a kind of a life pro tip, not just a debugging tip. I always tell students when they're working on their resume, write your resume, get it absolutely perfect, and then set it aside. Don't look at it for a week. When you come back a week later and look at it, you're going to see all kinds of little mistakes and typos that you hadn't noticed before. It's just something about how our brains work, right? One of the best ways to get fresh eyes on your code is to have someone else take a look at it, right? That other person isn't frustrated by the code. They don't have any investment in whether the code is good or not, or how much time you put into it. They're just looking at a piece of code. In class, this happens all the time. A student sits there staring at their code for a long time, stuck. I can see they're stuck. I walk over and I take a glance at their monitor and I can tell right away, oh, you typed in the wrong variable name. That doesn't happen because I'm any smarter than you. I'm not any smarter than you. It happens because I've got fresh eyes, and it also happens, honestly, because I've made that mistake 10,000 times before, so I recognize it. You're only making it for like the first or second time, so you don't realize it yet. If you do find yourself stuck on a bug for more than 10 minutes or so, I think that's probably also a good time to just reach out for some help. That could just be that other person that you call over to take a look. It also might mean raising your hand in class or emailing your instructor, scheduling time with a tutor. And unfortunately for that, that means you can't be a procrastinator, right? If you're doing your assignment 20 minutes before it's due, it's hard to give yourself that break or to reach out for some help from somebody. But as much as you can, if you can give yourself just a little bit of something else to think about for a few minutes, I guarantee that's going to help you find the error a little bit quicker. Now, just as kind of a final thought to leave you with, I would really encourage you to just be patient and to cut yourself some slack when you're debugging. Remember that something is causing the problem and it's just a matter of finding it. And keep in mind that even great programmers make mistakes and they get frustrated when they're debugging. So this doesn't mean that you're bad at this or that you're not a good programmer or something like that. Debugging is a skill just like anything else, and you're going to get better at it. Try using some of these suggestions when you run into problems, and maybe you'll start to find some strategies that really help you be less frustrated and more efficient with your coding.